You got your tests out, right? The first one is to define the following terms. Unit, you should have said something about a quantity that's measured. That's really all you had to say. You know what? If you listed a bunch of units, I would take it. If you just listed a bunch of units, you know, meters and grams and all that stuff, that's fine. Weight. Weight is how much gravity pulls on the matter in something, and mass is how much matter is actually in something. Okay, number 2, what physical quantity is measured with milligrams? You should have said mass. Okay, number 3, a soccer ball has a diameter of 69 centimeters. 5 students measure the ball's diameter and report it as, and then it gives the 5 measurements. Assume that all the students properly reported the significant figures for the device they used. Which measurement is most precise? Which measurement is most accurate? The most precise measurement would be the one with the most digits going out. And so that would be C, because it goes out to the hundreds, thousands, 10,000ths place, doesn't it? So that would be C. That's very, very precise. The one that is the most accurate, though, is actually B, which is the closest to 69 centimeters. Okay, so that would be B. So C and B are the 2 answers for number 3. Yes?
Why isn't it D?
Hang on. That's a really good question. Answer B is the most accurate. It has only one significant figure, and if you round the actual value to one significant figure, they are the same. But you're saying that that one is actually closer. I will give you B or D, because I see exactly why you went that route. And if you don't think like Jay Wiles, then you wouldn't necessarily do B, right? So, how many of you got B? How many of you got D? Okay. You know, and honestly, I mean, if you said 2 plus 2 is 5, I don't care how many of you said it, I'd say it's wrong. Okay, but I see your logic, and I don't think he's given enough information necessarily to go with that, so I can see it. Because it didn't say to give it to us in one significant figure. Matter of fact, the original digit was in 3 significant figures. And so I can see going to the one with 4 significant figures that's actually closer. So I'm with you, girl. Okay, number 4. This is why I said bring it up if you have a question. Okay. Number 4, you read in a lab notebook that a student used 31.4 grams of a chemical in an experiment. If the student properly reported the mass, which of the figures has some error in it? That would be the last digit, which would be the 4, right? Because that one is estimated. Okay. Number 5, how many significant figures are in the following measurements? So that first one, there are 5 significant figures there. The second one, there are only 2, because remember, those zeros are not to the right of the decimal at the end of the number, and therefore they are not between 2 significant figures either. So only the 1 and the 2 count. So there'd be 2 for B. And for C, there would be 4. The 1, the 9, the 3, and the 0 that's to the right of the decimal at the end of the number. Okay? Number 6, a student takes 3.1 grams from 15.12 gram sample of chemical. How much mass is left? Here you're going to subtract these 2 numbers, 15.12 grams. We're subtracting 3.1 grams. What do we get there?
12.
No, but give me more. 12.02, correct? That's what you get out of your calculator? Did I do it right? Yes? That's what you get out of your calculator, but the least precise goes to the 10ths place. Therefore, your answer has to go to the 10ths place, so your answer has to be 12.0 grams. That's what you have to have for the correct answer. If you do not have 12.0 grams, then you're going to have to take off some points. Matter of fact, let's see what they're each worth. Hang on. So we have 3, so it's 3 points apiece. Is that what he's doing? He's got that scored. Okay, that one's worth 3 points. So if you got the significant figures off and left it at 12.02 grams, you know, really you're going to have to miss those 3 points on that one, because that one's all about significant figures, isn't it? That's the whole reason. Anybody can subtract that. So that's the whole reason. Yes, ma'am?
But if you didn't put the point zeros, it's still wrong?
Definitely.
Okay.
Yeah, it is. I'm sorry. Yeah, that whole question was about significant figures. I'll tell you what, take off 2 points if you got the digit wrong and you put grams. Take off 1 point if you didn't put grams. How's that? We'll break it up a little. Okay. try at least. All right, let's see. The next one, convert 76 kilograms into grams. So you should have shown me the work. And you're supposed to be going to grams. There's 1,000 of these to every one of these. So this, you could have either written it this way, 6, 0. No, you couldn't. You couldn't. Okay, so let's do it. Times 10 to the third grams. To put this into scientific notation, you would have had to have that. And that's 3 significant figures, which is what you have there. So you needed that. You had to show it this way. Yes, Will, what'd you do?
Isn't it because we're converting, they're the exact same thing, wouldn't it not matter the significant figures?
Okay, I obviously confused you. What doesn't matter is these. You don't count these because they have an infinite number of significant figures. So your answer has to have the same number of significant figures as what you started with, your measured quantity. Now with that in mind, Will, if there's other ones like that on the test, go out into the hall and correct your number of significant figures right now, because I don't want you to miss a bunch of these. Were there others like that? Because you have to make sure that your answer is in the same number of significant figures as was this one. Yes?
So 76.0 has 3 significant figures?
Yes, because that is to the right of the decimal at the end of the number.
Right, so if I wrote it as 76.0, that's wrong just because it's not in the correct scientific order.
Did you write this?
Yeah.
I'll take it this time. From now on, though, when you have this, convert it. But it's the first test. I will take it this time. Good girl for asking. Okay. All right, did you do that? That's fine. Okay. All right, let's, but from now on, go ahead and switch it, all right? Number 8, it's kind of like, guys, it's kind of like on a math test, they count off if you leave an incomplete fraction. You know, what's it called when it's not in the right, it's not an incomplete fraction, it's a, that's the word, thank you, I haven't done math in a while. Improper fraction. You're not supposed to leave an improper fraction as an answer, are you? Right? Start thinking about this as an improper fraction. You're going to take it one step further to make it like it's supposed to look.
Oh, okay.
Okay? See, I knew that would work if I could get the word out. Thanks for the help, guys. Okay. I knew there was a picture I could give. Let's see. So let's go to the next one. So we have number 8, an object, 0.56 meters. We want to know the centimeters. So you go meters. You should have all this work there. This looks like this. And so this is going to give us 5,600 centimeters. You could have written it that way. That's 2 significant figures. That's 2 significant figures. You're in good shape that way. Okay. If you wanted to write this in scientific notation, it would be 5.6 times 10 to the third centimeters. Did I do it wrong?
It shouldn't have the 2 zeros.
I got 56.
Yeah, I just got 56.
Oh, you're so right. Thank you very much. I can't multiply today. Oh, I hope I'm not having one of those days. Thank you. You're right. You're right. This should be 56 because you move your decimal place over 2, and so it's 56 centimeters. Thank you, Jay. You should have said something. You were looking at me like, oh, say something. It's okay. Okay, you ready? Next, let's see. The English unit for mass is a slug. There are 14.59 kilograms in one slug. Okay. Convert 8.12 slugs into kilograms. So we put slugs down here. We put kilograms up here. We know that the 14.59 goes here, the 1 goes here. This will leave. You have 3 significant figures here. You have 4 here, so your answer has to be in 3 significant figures. And that is number 9. So your answer has to be 118 kilograms. Okay, because what you get out of your calculator, this is what I wanted to see. What you get out of your calculator is this. But you know you have to have 3 significant figures, so you're just going to chop all that off because that's less than 5, right? I just want to show you. That's why I'm bothering to do it. Okay. Any questions on that one? You okay? Look, if you did not do like you wanted to do on this test, you need to go back and you need to work on these again and take it again. You know, you're just getting started on chemistry, so take it again if you need to. Okay? Let's see. So then number 10, a sample of liquid occupies a volume of 0.092 kiloliters. What is the volume in milliliters? So we're going to go like this, kiloliters to liters, because that's what's in common, and then liters to milliliters. We know one of these gives 1,000 of these. We know one of these gives 1,000 of these. So we're going to have 0.092 times 10 to the 6th milliliters. So we're going to move this back too. So it'd be 9.2 times 10 to the 4th milliliters. Is that what you guys got? Two significant figures, two significant figures. Yep. You could have written it out as 92,000. That's fine. That also gives you two significant figures. Either way. Okay. Let's see. So then we're up to 11. If a small sphere has a volume of that, what is the volume in milliliters? So we have 0.00023 meters cubed, and we want to know what that is in milliliters. So I know I'm going to have to go to centimeters cubed to get across that bridge, aren't I? So I'm going to go like this, and I'm going to go meters to centimeters, and then I'm going to end up going centimeters cubed to milliliters, and that's a 1-to-1. This is the trickier one. You guys know to put a 1 here, to put your 100 in here, and then cube the whole thing. So this is going to end up being this, and I already showed you that, so I'm going to feel free to do that. Okay? All right, and so that's going to give us 1, 2, 3, 4. That's going to give me 2.3 times 10 to the 2nd, right? Milliliters. So, I hate doing these standing up here and not using my calculator to do it. Yes, that's the same thing as 230 mils, isn't it? Two significant figures. Okay? Let's see. Then we get to number 12. Iron has a density. Immediately my mind's going to destiny. Iron has a density of 7.85 grams per milliliter. The cylinder of iron has a volume of 3.4 liters. What is its mass? I have to have this in milliliters, so I'm going to go ahead and convert that. Okay, I know that rho equals mass over volume. We're looking for mass. So that means mass equals rho volume, which equals 7.85 grams per mil times the volume of 3.4 times 10 to the 3rd mils. And the mils will cancel. We have two significant figures there, three significant figures there. So 7.85 times 3.4. Okay. So that gives me two significant figures. That's going to give me 2.7. See, I messed myself up. Hang on. 5 times 3.4. 3 equals. It gives me 20. This is what comes out of my calculator. Okay. Can't leave that though, can I? Too many significant figures. I need to have two significant figures. So that's going to make, and I look at this, it's going to roll up. So it's going to be 27,000 grams. Or obviously you could write that as 2.7 times 10 to the 4th grams. Either way. Okay? Great. And if you need the scoring on these, it's in the back. And I'm counting each of his points as worth 3. So where he says one's worth 3 points, it's worth 9 points. If he says it's worth 2 points, it's worth 6 points. Okay? Because he's, yeah, just trust me on this. You get points just for writing your name, okay, so, or knowing your name. Let's just go there. So never add up your points. Always, you people that know me know this. You always start at 100 and subtract from 100 because I'm giving you the benefit of the doubt, is what I'm doing. All right? So always subtract what you miss from 100. Okay. And he says there's 28 points, and to me that rolls, the next thing that goes nicely into 100 is 33. And if there's 33, then there's 3 points for each of his points. Do you get my drift? That's how I want you to do it. And if you don't know what I just said, just let it go and trust me. Okay? Let's see. We got number 13. A beginner's bowling ball has a mass of 4.9 kilograms and a volume of 5.4 liters. Will it float in water, which has a density? So in other words, we have to find the density. It gives the density of water. So I'll dare to say that a bowling ball, I wouldn't think it would, but let's see. Okay, so we want to find rho equals mass over volume of the bowling ball. And we're giving the mass of the bowling ball is 4.9 kilograms, and the volume is 5.4 liters. And we're given water, its density, in grams per mil. So we're going to want this in grams per mil also. So this is going to be 4.9 times 10 to the third grams if you do the conversion. And this is going to be 5.4 times 10 to the third milliliters if you do the conversion, which you guys know how to do. So I'm going to put these up here and go 4.9 times 10 to the third grams divided by 5.4 times 10 to the third milliliters. And boy, that looks similar to 1. Divided by 5.4. Wow! The bowling ball will float. Wow! That's news to me. Okay, can you tell? 1. What comes out on my calculator is 0.907, and I can only have 2 significant figures, so I'm going to take that 7 and roll this up to a 1, and that's going to be grams per mil, which is less than 1 gram per mil. Therefore, the bowling ball will float. Wow! Did I do it wrong, Piper?
No.
Okay.
I was just wondering because I thought the question was just asking, like, will it float? So
And you
I
said yes.
0.907, and I just said, yes, it will float.
I will not count off for the significant figures in this case because you didn't know. It's fine. I'm going to steal from this nice man here. My fingers are turning black. And it wouldn't matter except for my daughter got me this nice Lily Pulitzer, and I don't want to turn it black because I can't replace it. And I'm cleaning myself with vinegar. I love it. Okay, here, we'll just throw that over there. All right, let's do the last one. So Piper, I'm with you. So if you just did the math, figured it out, you said it'll float, you don't get counted off for the significant figures. High five across the room that you caught that. That's very good. Okay, because somebody else at home did that, I guarantee it. So guys, always ask your questions. If you did it, somebody else at home will have done it also. So you're benefiting the body of Christ by asking. You guys okay? Okay. I know I smell like a salad. Don't go there. All right, number 14. What is the length of the bar in the following illustration? Hopefully you remembered. If we use just what the measurement is, we would go, let's see, 20.3, whatever. So I'm going to say 23 point whatever, and that's centimeters, but we can't leave it at that, can we? Because they moved it on us, didn't they? So we have to subtract a 1, right? So it's actually 22 point something. So your answer should have been 22. Did I do it wrong? Oh, sorry. I'm looking at this all wrong, aren't I? I'm looking at the 0.2. It looks like 20.2 centimeters. If you subtract 1, it would be 19.2, and we've got to have something out here, don't we?
I got 19.31.
That's all I can say.
I got 3.3.
No, I think you're right. I think it is 19.3. I'm having trouble seeing it, even with my glasses. I got to get new glasses. These are small lines. Okay, so let's go with 19.3 something. How's that? 19.3 something. If you did 20.3 something, take off 1 point because you forgot to subtract the 1 centimeter. Okay, but this is the important part, is that it has, the important part is that you have this last digit estimated. You should have this fourth digit here that you estimated. Okay? That's what he's looking for there. I'm glad you can see better than I can. I've got to get new glasses. Okay. All right, and then to actually, like I said, to actually get your grade, if you're going to keep what you did there, he tells you how many points each one's worth. And like 13 is worth, well, here, let's look at what he's got for 13. He's got it worth 9 points. It says take off a half if the student doesn't round the density to 2 significant figures. You know why we're not going to? He didn't tell you he wanted the number, just like you just said. So we're not doing that. You know what? You know what we're going to do? Let's change the whole thing. Because that's how I am. There were 14 problems on that test, right?
Miss Grady's?
Is that correct? Each problem's worth 7 points. If you miss the significant figures on one, if you miss the significant figures on one of those that all the problem was about with significant figures, take off 4 points, not the full 7 if you have the work there and all. Okay? Yes, Jay.
Okay, so on number 7, I did a really silly thing, and instead of putting my 1,000 with the grams, I put it with the kilograms, and I don't normally do that. This is the first time I've ever done that, but I had the proper amount of significant figures. Can I get anything for that or no?
Yeah, take off half. Take off like 4 points. How's that?
7 points?
They're 7 points apiece. That's if we take 100 and divide it by 14. That's where I got that.
Okay.
Okay?